Children, it is a daily practice questions of physics for day 2. Now take the first question. 4 alternatives are given for each of the following questions. Choose the correct alternative and write the complete answer along with its letter of alphabet. Here there are 3 questions. They are the multiple choice questions. Each carry 1 mark. So let us see the first question. The device used to measure the current is. You know that the device used to measure the current is ammeter. Here the 4 options are: option A is galvanometer, option B is ammeter, option C is voltmeter, and option D is rheostat. You know that galvanometer is a device to detect the flow of electric current, and ammeter is a device to measure the current in the circuit, and voltmeter is a device to find the potential difference across the 2 points, and rheostat is a device for the variable resistance. So here what is the answer? The answer is B, that is ammeter. So you write answer B, ammeter. Next, let us take the second question. Which of the following is not a characteristic of magnetic lines of force? Which of the following is not a characteristic of magnetic lines of force? The first option A is emerge from the North Pole. That is the characteristic of magnetic lines of force, and intersect each other. You know that the magnetic lines of force do not intersect each other. Here only you can make out the answer. Here it is not a characteristic of magnetic lines of force. Merge in South Pole, that is the characteristic, and do not intersect each other, that is also the characteristic of the magnetic lines of force. So then what is the answer? Which of the following is not a characteristic of magnetic lines of force? That is intersect each other. So write the option B is the answer. Answer option B, intersect each other. It is not a characteristic of magnetic lines of force. Next one. Which type of lens you prefer to use in reading small words in newspaper? Here the 4 options are: a concave lens with focal length 50 cm, convex lens with focal length 50 cm, and concave lens with focal length 5 cm, convex lens with focal length 5 cm. Here the reading lens is convex lens. Reading lens is convex lens, so you can't choose these 2 options. But here, as the focal length decreases, its magnification goes on, increases. So here, if you compare this and this, the option D is the suitable answer. So you write that here. What is the answer? D. Answer D, convex lens with focal length 5 cm. Convex lens with focal length 5 cm. Next, let us come to the short answer type questions. That is the second main. Answer the following questions. 2 questions are there, each carry 1 mark. So, fourth question. Power of a lens is 2 diopter. What does it mean? Here, P is 2D. It is given that P is equals to 2D, and it is a positive. So, the positive sign of the power indicates that it is a convex lens. It is a convex lens. And what is its focal length? So its focal length becomes F is equals to 1 by P, that is 1 by 2, that equals 0 is 0.5 meter. So how you can explain it? Power of a lens is 2 diopter. What does it mean? It means it is a convex lens with focal length 0.5 meter. So that is 0.5 meter means you can have that is 50 centimeter. So you can write 0.5 meter or 50 centimeter. Here power of a lens is to a diopter. What does it mean? So what is the answer you are going to write? It means it is a convex lens with focal length 0.5 meter or 50 centimeter. Next, so we take the fifth question. In which point of a lens the light ray do not bend? So what is the question? In which point of a lens the light ray do not bend? So you write that here it is already know that through the optic center of a lens the light ray do not bend. So the ray which passes through the optic center of a lens do not bend, so do not undergo refraction, do not refracts. So you write that through the optic center or optical center or optic center of a lens the light ray do not bend. The light ray do not bend. Next, let us come to the third main question. Answer the following questions. There are 2 marks questions, 3 questions are there. On what factors did the resistance of a conductor depends? Then what is the answer for this question? So the resistance of a conductor depends on length of the conductor, area of cross section of the conductor, and nature of the material of the conductor. It depends upon 3 factors. One is the length of the conductor, second one is the area of cross section of the conductor, and third one is the nature of the material of the conductor. So you write that resistance of a conductor depends on, first one you write length of the conductor, so first one you write length of the conductor, length of the conductor. So resistance R of a conductor is directly proportional to its length. So write that resistance R of a conductor is directly proportional to its length L. That you can write R is proportional to L. Second one you write area of cross section, area of cross section of a conductor. So the resistance of a conductor is inversely proportional to its area of cross section A. So write here resistance R of a conductor is inversely proportional to its area of cross section A. Area of cross section A, that you can write R is proportional to 1 by A. Third one, you take nature of the material of the conductor. Nature of the material of the conductor. So the factor affecting the resistance of a conductor depends on length of the conductor, area of cross section of a conductor, and nature of the material of the conductor. It is a seventh question. Draw a ray diagram of image formed when an object is placed beyond 2f1 in front of a convex lens. Children, method of drawing the ray diagram for the image formation of the object when the object is kept beyond 2f1 is already done in the video. Children, view the video of the method of drawing the ray diagram of the object when it is kept beyond 2f1 in front of convex lens and learn the method and you draw the ray diagram. Now let us take the question number 8. Compare the power used in each of the following. 6-volt battery in series with 1 ohm and 2 ohm resistors and 4-volt battery in parallel with 12 ohm and 2 ohm resistors. And in your textbook there is a question to find the power used in each of the 2 ohm resistors. Here in both the cases 2 ohm resistors are there. In that question here asked to find the power used in 2 ohm resistors, but here the question is compare the power used in each of the following. So here first we have to find the power used in 6-volt battery in series with 1 ohm and 2 ohm resistors, and again we have to find the power used in 4-volt battery in parallel with 12 ohm and 2 ohm resistors. So let us find here. First you take A. Then here what is given? V is equals to 6V is given, and resistance we have to find out. Here it is a series connection. So here 1 ohm resistor and 2 ohm resistors are connected in series. So here R, if you take R1 you take 1 ohm and R2 you take 2 ohm. Then equivalent resistance R becomes, as there is a series connection, that is equals to the sum of the resistances. So it becomes 1 plus 2 equals 3 ohm. Now you know the formula for power. P equals V square by R equals V6. So you write 6 square by R. X square by R is 3. Then it becomes 36. 6 square is 6 into 6 by 3, or otherwise you can write 6 into 6 by 3. 3 ones are 3 twos are 6 twos are 12. 12. Then you take B. Here V is equals to 4 volt and R we have to find out. So you take R1 is equals to 12 ohm and R2 is equals to 2 ohm. R2 is equals to 2 ohm. Then here to get R, as they are in the parallel connection, so you take the relation that 1 by R equals 1 by R1 plus 1 by R2. Then that equals 1 by R equals 1 by R equals 1 by R1 is 12 plus 1 by R2. 1 by R2 is 1 by 2. That equals, now you take the LCM. What is the LCM of 2 and 12? LCM of 12 and 2, you know, 12 is in the table of 2, so the LCM becomes 12. Then 12 ones are 12, 1 ones are 1, 2 6 are 12, 1 6 are 6. Then it becomes 7 by 12. Therefore, you can take that R equals 12 by 7. Then you write P equals V square by R, that is V is 4 volt, so you write 4 square by R. R is 12 by 7, that equals 4 into 4 into, that take the reciprocal, that becomes 7 by 12. Then 4 ones are 4 threes are, so you will get 4 sevens are 28. 28 divided by 3 you will get, so you got that P is equals, so divide 28 by 3, so 3 nines are 27, 8 minus 1 is 1, then you put the point, take the 0 here, 3 threes are 9, 1 again, so here 3 is recurring, so you write 9.3 watts. You got that power used in 6 volt battery in series with 1 ohm and 2 ohm resistors is 12 watt, and the power used in 4 volt battery in parallel with 12 ohm and 2 ohm resistors is 9.3 watts. So you write that. So you write that power used in series with, what is that, a 6 volt battery in series with 1 ohm and 2 ohm resistors is how much? We got that, that is 12 watt. Power used in four volt battery in parallel with 12 ohm and 2 ohm resistors, and 2 ohm resistors is how much? Is 9.3 watt. Now you take the fourth main question. Answer the following questions. There are 3 mass questions. 3 questions are there. Draw a neat diagram of electric motor and label carbon brushes and split rings. Children, it is a diagram of the electric motor. Here you observe the diagram, and the carbon brushes are X and Y, and also label the split rings P and Q. Here the split rings P and Q, so you can label the split rings and carbon brushes. So here is a carbon brushes, this and this, X and Y, and P and Q. P and Q are the split rings. Now you take the 10th question. Explain an experiment to show convex lens converges light rays. And it is a choice question. Our question is there, and in our question there are 2 sub questions. First question is, refractive index of benzene is 1.50. What does it mean? And second question is, in which direction the light bends when it moves from air into benzene solution? So now first let us write the answer to the first question. An experiment to show convex lens converges light rays. To do this experiment, you take a convex lens and a sheet of paper and a meter scale. Hold a convex lens in the hand, direct it towards the sun. Focus the light from the sun on a sheet of paper. Obtain a sharp, bright image of the sun. Hold the paper and the lens in the same position for a while. Keep observing the paper. After a while, the paper begins to burn, producing smoke. It may even catch fire. This experiment clears that when a high intense parallel beam of light falls on a convex lens, it converges and meet at the focus on the other side of the lens. So you can say that convex lens converges light rays. Now let us write the answer. Take a convex lens a sheet of paper, a sheet of paper. To show that convex lens converges light rays, these two are enough, convex lens and a sheet of paper. So what you have to do here? Hold a convex lens in the hand. Hold the convex lens in the hand, direct it towards the sun. Focus the light from the sun on a sheet of paper. On a sheet of paper, obtain a sharp bright image of the sun. Obtain a bright, sharp image of the sun. Hold the paper and the lens in the same position for a while. Hold the paper and the lens in position for a while. Keep observing the paper. Keep observing the paper. Keep observing the paper. After a while, the paper begins to burn. Producing smoke. It may even catch fire. This is because the light from the sun travels in the form of parallel rays. Light from the sun travels in the form of parallel rays. These rays are converged by the lens forming a bright spot on the paper. When high intense parallel beam of light falls on a convex lens, it converges and meets at the focus on the other side of the lens. It means when a high intense parallel beam of light falls on a convex lens, it converges and meets at the focus on the other side of the lens. It converges and meets at the focus on the other side of the lens. In this way, we can conclude that according to the question, what you can conclude, convex lens converges light rays. Now you take the choice question. The refractive index of a benzene is 1.50. What does it mean? So write the answer here. First one, refractive index of a benzene is 1.50. It means the ratio of speed of light in air or vacuum we take, the ratio of speed of light in air Also you can take vacuum. Vacuum. To that of benzene is 1.50. So what does it mean? It means the ratio of, it means that the ratio of speed of light in air, also you can take vacuum, to that of benzene is 1.50. So you can write refractive index of benzene equals speed of light in vacuum or air, you take speed of light in air, also you can take vacuum, by speed of light in benzene equals what? 1.50. The sub question, one more question, that is second question. In which direction the light bends when it moves from air into benzene solution? So right, light travels faster in rarer medium air and slower in denser medium benzene. Denser medium benzene. As a ray of light here, as ray of light moves from air into benzene solution, ray of light moves from air to air into benzene solution, air into solution, it bends towards the normal. It bends towards the normal. Now question number 11. What is solar cell? List out the uses of solar cell and its limitations. Now let us write what is solar cell. So what is solar cell? A solar cell is a device which can convert the radiant energy of the sun, means solar energy, into electrical energy directly. So write solar cell. What is solar cell? A solar cell is a device which can convert the radiant energy of the sun that is called solar energy. Directly into electrical energy. Directly into electrical energy. So next here, list out the uses of solar cell and its limitations. First let us write the uses of solar cell. So write uses of solar cell. So what are the uses of solar cell? So directly it converts solar energy into electrical energy. So solar cells are cost effective, particularly in remote areas where cost on installation of other modes of energy is very high. So you write solar cell can provide power, can be used in remote and isolated locations. In remote and isolated locations. Examples: to provide power to lighthouses, to provide power to offshore oil drilling platforms, to provide power to artificial satellites, power to artificial satellites and other spacecrafts. And one more thing, here solar cell do not consume any fuel to generate electricity, but instead convert sunlight directly into electricity. So it is right. Solar cell do not consume any fuel. So it does not cause any pollution. That is also one of the important use of the solar cell. Then next about the limitations. So what are the limitations? So you write limitations of solar cell. So what is the third part? Write the limitations of solar cell. Then what are the limitations of the solar cell. You know that the efficiency of solar cells is very low. It produces direct current which needs to be converted to alternating current, and the cost of installation of solar cells is very high. So these are some limitations. So you write first one, the efficiency of solar cells is very low. Second one you write, it produces direct current. It produces direct current which needs to be converted into alternating current, which needs to be converted into alternating current. Alternating current. The cost of installation of solar cells is very high. Cost of installation of solar cells is very high. These are some limitations. Next, let us take the next question. Fifth main question. Answer the following questions. Two questions are there. Each carry 4 marks. How fuse is helpful in domestic electric circuits? Why does the cord of an electric heater not glow while the heating filament or heating element does? So let us write the fuse is a safety device used to protect an electric circuit from overloading or short circuiting. So write that answer for the first question. Fuse is a safety device used to protect an electric circuit from overloading or short circuiting. From overloading or short circuiting. The working of an electric fuse is based on the heating effect of current. A fuse wire has low melting point and high resistance. Fuse wire works on heating effect of electric current. It has, or you write, a fuse wire has low melting point and high resistance. Low melting point and high resistance. It is connected in series with the live wire. It is connected in series with the live wire. When an excessive current flows through it, when an excessive current flows through it, the wire melts and the circuit is broken. Circuit is broken. The electric current stops flowing immediately. Stops flowing immediately. Electric appliances like TV, computer, etc. are thus prevented from getting damaged. From getting damaged. In this way, fuse is helpful in domestic electric circuits. The second question, why does the cord of an electric heater not glow while the heating element does? Now let us write the answer to the question that why does the cord of an electric heater not glow while the heating element does? Here cord is having lower resistance and heating element is having higher resistance. Both the cord and the heating element of an electric heater carry the same current, but the heating element becomes hot due to its high resistance and begins to glow. The cord remains cold due to its low resistance and does not glow. So you write that both the cord and the heating element of an electric heater carry the same current. And you write that heating element is having high resistance heating element has high resistance and cord has low resistance. The heating element becomes hot becomes hot due to its high resistance. Because you know that H is equals to I square RT. As the resistance increases, heat producer also increases. The cord remains cold due to its low resistance. Due to its low resistance. So right, and does not glue. Does not glue. The cord remains cold due to its low resistance and does not glue. But heating element becomes hot and it glows. 13th question. Name the rule used to find direction of induced current in generator and define it. And it is having the question B. How can we increase electric current in generator? And it is a choice question. The choice question is write the construction and working of a generator. Now let us write the answer to the question. A. Name the rule used to find direction of induced current in generator, and we have to write the definition of this rule. So what is that rule? That is Fleming's right hand rule. This gives the direction of induced current. Fleming's right hand rule gives the direction of induced current in a conductor. Write that Fleming's right hand rule. Right hand rule gives the, or Fleming's right hand rule is used to find the direction of induced current in generator. Then define it. Let us write the definition of Fleming's right hand rule, or take statement of Fleming's right hand rule. Right hand rule. So let us write the statement. What is the statement? If we hold the thumb, the forefinger and the central finger of a right hand mutually perpendicular to each other, and if the forefinger points in the direction of the magnetic field, the thumb in the direction of the motion of the conductor, then the central finger points in the direction of the induced current in the conductor. So write, if we hold the thumb, the forefinger and the central finger of right hand mutually perpendicular to each other. mutually perpendicular to each other, and if forefinger points in the direction of the magnetic field, the thumb in the direction of motion of the conductor, thumb in the direction of the motion of the conductor, then the central finger points in the direction of the induced current in the conductor. Induced current in the conductor. That is the definition of the Fleming's right hand rule, or also you can say that is the statement of the Fleming's right hand rule. Now, how can we increase electric current in generator? To increase the electric current in the generator, we can increase the number of turns in the coil, and also you can increase the speed of the rotation of the armature, and also you can increase the strength of the magnetic field used. Write the answer for the B question. Electric current in a generator can be increased. So here the question is, how can we increase electric current in generator? So write, electric current in generator can be increased. Generator can be increased. Electric current in generator can be increased by increasing the number of turns of the coil. Can be increased by increasing the number of turns in the coil. Number of turns in the coil. As the number of turns increases, the amount of electric current in the generator also increases. Second one you can write, by increasing the speed of rotation of the coil. By increasing the speed of rotation of the coil. Third one, by increasing the strength of the magnetic field. By increasing the strength of the magnetic field. By increasing the number of turns and speed of rotation of the coil, and also by increasing the strength of the magnetic field. These are the different ways of increasing the electric current in the generator. The next here, the choice question is write the construction and working of generator. Children, write the construction and working of a generator. It is a figure of the generator. Now you write the construction of a generator. An electric generator consists of a rotating rectangular coil ABCD placed between two poles of a permanent magnet. The two ends of this coil are connected to the two rings R1 and R2. R1 and R2. The inner side of these rings are made insulated. The two conducting stationary brushes B1 and B2 are kept pressed separately on the rings R1 and R2. Here B1 is in connection with R1 and B2 is in connection with R2. The two rings R1 and R2 are internally attached to an axle. The axle may be mechanically rotated from outside to rotate the coil inside the magnetic field. Outer ends of the two brushes are connected to the galvanometer to show the flow of current in the given external circuit. Here B1 and B2 are connected to the two ends of the galvanometer to detect the flow of electric current in the circuit. That is about the construction. Now about the working of a generator. When the axle attached to the two rings is rotated such that the arm AB moves up and the arm CD moves down in the magnetic field produced by the permanent magnet. When the axle is rotated, arm AB moves up and arm CD moves down in the magnetic field produced by the permanent magnet. Let us say that the coil ABCD is rotated clockwise. By applying Fleming's right hand rule, the induced currents are set up in these arms along the direction ABCD. That is, in AB it is from A to B, in CD it is from C to D. That is, from A to B and C to D in the direction ABCD. Thus, an induced current flows in the direction ABCD. This means that the current in the external circuit flows from B2 to B1. As the current moves from A to B, B to C, C to D, so in the external circuit, the current moves from in the opposite direction of the movement of the coil, that is from B2 to B1. The current moves from B2 to B1. After half rotation, arm CD is moving up and AB moving down. As a result, the direction of the induced current in both the arms change. Here, first it was A to B. Now it is from B to A and from D to C. B to A and D to C. So as a result, the direction of the induced current in both the arms changes, giving rise to the net induced current in the direction DCBA. That is, from D to C and B to A. The current in the external circuit now flows from B1 to B2. B1 to B2. That is, so according to the Fleming's rule, the current moves in the direction DCBA, and in the external circuit, the direction of the current changes. That is from B1 to B2. In the first half rotation, it is from B2 to B1. In the second half rotation, it is B1 to B2. Thus, after every half rotation, the polarity of the current in the respective arms changes. Such a current which changes direction after equal intervals of time is called an alternating current. This device is called an AC generator. To get a direct current means the direction of the current which does not change with the time. That is the direct current. So what you have to use? A split ring type commutator must be used. So So that is about the construction and working of the generator.